Alright, so I am Miss Webb and I'm going to be doing the radicals in algebra with you. This video is going to be a little longer just because there's so much I have to cover. It's all super simple though, and I give you plenty of examples, so please feel free to skip around, go where you need to go, and don't feel like you have to sit through all the examples if you understand what you're doing. So I'm just going to straight jump into the algebra. So the first 5 examples are just algebra. If you don't need that, then the radicals will start later on. So example 1, I tell you if 13x equals 52, then 4x equals something. We need to find what that is. So just like you've been taught before, we're going to want to solve for x first. So I have 13x is equal to 52. This is actually a one-step problem because it only takes one step to solve. I want to get that x by itself. To do that, you have to undo that multiplication. So we're going to divide both sides by 13. When you do that on the left, it cancels out and leaves you with just x. And then finally, 52 divided by 13 gives you 4. Now, on the TSI test, there are not calculators for every single problem. If they want you to use a calculator, then you will have the opportunity. It'll pop up, it'll show up there. If not, you're going to have to do the longhand division. You're going to have to do guess and check. I would just see how many times 13 goes into 52. Start with 2, that gives you 26, half 52, so on and so forth. Now, this is just the first part of this problem because I want to know what 4x is. Let me change that color, you can't see it. 4x. So what I'm going to do now is I'm going to take 4, and instead of x, I'm going to write what we just found x to be over here on the left. So 4 times 4 equals what? And of course, that is 16. So I know that if 13x equals 52, then 4x is 16. Alright, don't freak out. Example 2 looks super scary. Maybe not, maybe that's just me. But I tell you, if x divided by 2 equals -5, then what is 6x? And what's scary about this is that fraction. For some reason in our mind, we're like, oh my gosh, it's a fraction. I can't do it. I can't do any sort of math. Let me just give up. But that's not the case here. It's super simple. So I'm just going to rewrite it over to the right. So x divided by 2 is equal to -5. Now, people can tell you, oh, you're just going to multiply by this, or you're just going to divide by this. The easiest way to do this is just to multiply both sides by the denominator of the fraction. What that does is gets rid of the fraction and only leaves what's on top. So I have x equals, and -5 times 2 is -10. So remember, we multiply both sides by the denominator's number. I now know what x is, so I now can find out what 6x is equal to. I'm going to replace the x with our -10. So 6 times -10 gives me -60. So my answer for example 2 is -60. Example 3 is just like example 2, except there's an extra step in there. There are 2 different ways to do this, but I'm going to get the x by itself on the left side, the 1/2 x alone on the left side first. And that means I need to get rid of this -12. I need to move it to the right side. So I need to do the opposite of subtraction and add it. So like I said, I'm going to add 12 to both sides. When I do it on the left, it cancels out, and I'm just left with that 1/2 x is equal to 4 plus 12, hopefully you can do this in your head, is 16. Now you're like, oh my gosh, Miss Webb, the x isn't in the top. What am I supposed to do? All you're going to do is rewrite it just like example 2. So now it's going to be x over 2 equals 16. And just like example 2, I took the denominator. In this case, it also happens to be 2. And I'm going to multiply both sides by 2. Remember, when I do that, when I multiply by the denominator, I'm just left with whatever's on the top. And then 16 times 2 gives me 32 for x. But remember, I want to find out what -2x is. So -2, I replace that x with a 32. A negative times a positive is going to give you a negative, and 2 times 32 leaves us with 64. So if 1/2 x minus 12 equals 4, then -2x is equal to -64. Alright, example 4, if 2 parentheses 3 minus x is equal to 16 parentheses x plus 1, then I want you to find x plus 4. So I'm going to rewrite it like I have been to 3 minus x is equal to 16 times x plus 1. So remember, your main goal in these is to find x first. In order to do that, we have to do something called distributing, which I'm sure you're all super familiar with. So first I'm going to do 2 times 3, which gives me 6, minus 2 times x is 2x. And that's equal to, we're going to do the same thing on the right side. We're going to distribute. 16 times x gives me 16x. Plus, I'm going to distribute the 16 to the 1. 16 times 1 gives me 16. Now I look at my left side, there's nothing I can combine together there. I look at my right side, there's nothing I can combine together there. So now I need to start moving stuff. I usually like to move the smaller x, and in this case, it's that minus 2x. So I'm going to add 2x to both sides. When I do that on the left, it cancels out, and I'm just left with 6 is equal to, I now have to do 16x plus 2x, so 18x, and I still have that plus 16 because I haven't done anything with it. Now I need to get this 18x by itself, so I need to get rid of this plus 16, and to move it to the left side, we do the opposite, so we're going to subtract 16 from both sides. It cancels out on the right, so I'm left with 18x on the right side. And 6 minus 16 leaves me with negative 10. So make sure you're really careful with your negatives and your positives here. Now I'm running out of room a little bit, so I'm going to continue up here. So I have negative 10 is equal to 18x. I need to divide by whatever is in front of the x. So I'm going to divide both sides by 18. 8 cancels out on the right, and I'm left with x is equal to negative 10 over 18. Now, I do want to reduce it. I don't want a proper fraction. I can leave it improper, but I do want it to be a reduced improper. So I'm going to divide both sides, or the top and the bottom, by 2. So I'm left with negative 10 divided by 2 is 5. 18 divided by 2 is 9. So now I do have x, and I want to know what x plus 4 is. Well, I know that my x is negative 5 over 9. Plus, I have to turn this 4 into a fraction now. So I am going to do 4 times 9, because I have to put it in terms of my denominator, which is 36 over 9. Because if I did 36 divided by 9, it would give me back to the 4. So now, I'm just going to rewrite it so you can see it a little better. 36 over 9 in the front, minus 5 over 9. When I do 36 minus 5, I end up with 31 over 9, and we're just going to leave it right there as it is. These ones are a little more difficult just because you have to bring in fractions, and they're probably going to be a non-calculator question, so just make sure you are familiar with your fractions. So for example 5, I am going to do something a little different. I'm actually not going to solve this for you. I'm leaving this for you to do on your own to kind of check yourself. I am going to give you the final answer. When you finish this, you should get that 6x plus 3 is 27. So remember, that is not your x value of what you do in the first part. You still have to solve for x first and then plug it in. So if you solve for x and plug it in and get 27, you're good to go. If you do not, please make sure you ask questions. I do have live sessions. I have those times at the end of this video. Alright, so we just did algebra, and we are now going to jump into radicals. The first thing that's really important is knowing your perfect squares. You should at least know them through 12, if not more. And what a perfect square is basically is a number. So it's a number that has a perfect square root. So it's not a decimal number. You don't break it down. So like 1 squared is 1. If I was to take the square root of 1, it would be 1. 2 squared is 4. If I was to take the square root of 4, it would be 2, because 2 times 2 is 4. So I'm just going to go through, fill this out. If you don't have this already or don't have this memorized, please make sure you do. It's going to make your life a whole lot easier. 3 squared is 9. 4 squared, 16. Remember, you're just multiplying the number by itself. So 4 times 4, 3 times 3. 5 times 5 for 5 squared is 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81, 10 squared, 100, 11 squared, 121, and 12 squared, 144. Now, if you know more, that's awesome. There are some more in the examples, but please make sure you have this minimum answered, because like I said, like we've said before, you will not have a calculator for everything, and if you know these already off the bat, it makes it a lot quicker for your TSI. All right, so this next part, it's on your worksheet. There are more examples than what I'm showing here, but I just want to show you so you can get the hang of it. So this first part says the square root of 25 is equal to 5 because 5 squared is equal to 25. That's what we just talked about in the perfect squares. So the square root of 36 is equal to 6 because what? We talked about 6 squared being equal to 36. So this is just to get you familiar with the language. Now that's in terms of numbers, but we're also going to deal with variables. So you have the square root of a to the 6th is equal to a cubed. And that's because if you were to square a cubed, you would get a to the 6th. So now when I look at the square root of m to the 16th, if you look here, both of these examples under the square root are even numbers. And their answers are exponents that you would get if you divided the original by 2. So I know that the square root of m to the 16th is equal to m to the 8th because if I was to take m to the 8th and square it, I would get m to the 16th. It's just like that first example. Like I said, this is just to get you familiar with the language. It's really important to know, though, that the easiest way is just to divide the exponent by 2. So here we've got some number examples. We're going to go through those first. The square root of 16. You should know this straight off the bat. It is on your perfect squares. You should know that this is equal to 4. I'm going to go write down, I want the negative square root of 100. So if you have a negative outside, it's going to stay negative. Nothing happens to it. Now, what is the square root of 100? You should know this. It's one of your perfect squares. It is 10. So the negative square root of 100 is equal to negative 10. Now, the next two examples are not perfect squares, but what you need to do is break them down into perfect squares. So I want to think about numbers that go into 125. I know for sure 5 goes into 125 because it ends in a 5, but that's not a perfect square. Now, I do know that if I take 125 and I divide it by 25, that leaves me with 5. So right here, 25 times 5 would get me back to that 125. Now, when I'm looking at this for my final answer, I know there is a square root of 25. I know that 25 is a perfect square. So what is the square root of 25? It's 5. But I do not know, or there isn't a perfect square of 5. So all you have to do is write it right next to that whole number. So the square root of 125 is equal to 5 root 5. So now for 180, I am going to show you how I kind of go through the process. I think about my factors. So I know for sure it's 1 and 180. I know it's 2 and 90. Then it is 3 and 60, 4 and 45, and then it is 5 and 36. Now you could keep going if you want, but I'm going to start here and work from here. I have my factors listed out, and I want to see if any of these or which one of these are perfect squares. I know 1 is and 180 is not. That doesn't really get me anywhere though. 2 and 90, neither of those are perfect squares. 3 and 60, neither of those are perfect squares. 4 and 45, 4 is, so I'm going to leave it. And then I have 5 and 36, 36s. You want the biggest perfect square, basically. So I could do 4 and 45, but I would have to break down this 45 again because it is 9 times 5. So I'm going to cross that out, and I'm actually going to go with 5 and 36. So I decided that I was going to say that the square root of 180 is equal to the square root of 36 times the square root of 5. Now I know that I can break down the square root of 36 because it is a perfect square. The square root of 36 is 6. I cannot break down the square root of 5. There's not a perfect square in it, anything like that. So I'm just going to rewrite it right next to 6. So the square root of 180 simplifies down to 6 root 5. Now I have two variable examples here because you have plenty on your worksheet, and these ones that are just by themselves are pretty straightforward. I am going to start with this one on the right. the square root of a to the 8th. Remember, if it is an even exponent and you're taking the square root, all you have to do is write the variable and divide the exponent by 2. So 8 divided by 2 gives me 4. So the square root of a to the 8th is equal to a to the 4th. Now this one on the left, you have m to the 11th. I want to know the square root of that. There is one extra step in this, but it's super simple, I promise. So just like the numbers, we're going to break it down. You're going to break it down into the biggest even number that you can take out of 11, which is 10. So m to the 10th times the square root of m. And just like we did with a to the 8th, we're going to divide this 10 by 2. So the square root of m to the 10th is m to the 5th. 10 divided by 2 is 5. And then you just rewrite the square root of m next to it. That's it. You're done. This is the square root of m to the 11th. Alright, so now we're getting into the combination examples that have a number and a variable or multiple variables. You're just going to want to break these down into steps. You'll do the numbers first and then the variables separate, and it'll go smooth. It does look really intimidating at first, but it's all alright. So when I look at this first example, I'm going to break it apart into the square root of 6 times the square root of x cubed. I'm going to deal with my number first. When I think about 6, its factors are 1 and 6. 1 is the only perfect square. It doesn't get us anywhere. And then 2 and 3. Neither of those are perfect squares. So we actually cannot simplify the square root of 6. So I'm going to go ahead underneath and just write the square root of 6. Now when I look at the square root of x cubed, remember we take the highest even number. So square root of x squared times the square root of x. Remember 3 is 2 plus 1. Whenever you take the square root of x squared, that just leaves you with x. And I can't do anything with the square root of x, so we leave it as is. Now just to write it nice and neat, I know that 6 and x are underneath the square root, and I have an x on the outside. So x times the square root of, and then you just put 6x on the inside. Now there are a lot of steps in here that you can skip. I'm going to do one more in-depth example, and then the other examples I am going to skip steps just to make it shown that you don't have to write it all out. So this example over here, the square root of 32, m to the 7th, n to the 11th, that's what I'm going to work on next. So when I think about the square root of 32, you need to break it apart into two numbers. I'm going to break it apart into 16 and 2 because 16 times 2 gives me 32. Now I know that I can take the square root of 16 and I know that is 4, but I cannot take the square root of 2, so we're going to leave it as 4 root 2. Now the next part we're going to take care of is the square root of m to the 7th. I'm going to break it down into the square root of m to the 6th and then the square root of m. Remember, when you have an even number underneath the square root sign, to find the square root of it, all you do is divide by 2. So the square root of m to the 6th is just m to the 3rd, and we leave the square root of m. And then your last step is to deal with the square root of n to the 11th, which is the square root of n to the 10th times the square root of n. This is going to equal to n to the 5th on the outside, square root of n. Now your final step of this is to look at everything on the outside. So I know that I have 4 m to the 3rd and n to the 5th on the outside. So I'm just going to write them right next to each other. 4 m to the 3rd, n to the 5th is all on the outside of the square root symbol. So now everything on the inside, I have the square root of 2, the square root of m, the square root of n. All we do is write that all underneath the sign. So 2mn, and here's your final answer. It looks nasty, but that's all you have to do. Don't have to do anything else with it. So now for these last two examples, I am going to kind of do this shorthanded way. I know that the square root of 49 is 7, so nothing is going to go inside the square root for 49. Now, a to the 4th, 4 is even, so the square root of that is just a squared. And b to the 12th, 12 is even, so I divide that by 2, and I get b to the 6th. So the square root of 49, a to the 4th, b to the 12th, is 7a squared b to the 6th. Now for this last example, I have 63, which I would break that down into 9 and 7, the square root of each of those. So I know outside of my radical symbol, which I'm going to go ahead and write, is going to be the square root of 9, which is 3. And on the inside, I'm going to have 7 because I can't take the square root of that. Now the next thing I deal with is this x to the 4th. It is even, so all you do is divide the exponent by 2. It goes on the outside as x squared. And then you have y left. Y, there's no exponent there, but you have to remember, if there's no exponent, it means 1. I can't take the square root of just y, so it goes underneath the radical. And the square root of 63x to the 4th y is 3x squared times the square root of 7y. So now the last part of this video focuses in on laws of exponents. You do see them on the TSI. You may or may not have seen them recently, so we are going to just go through the 6 laws with an example of each, just to make sure that we do hit them. What this says is if your bases are the same and your exponents are different and you're multiplying them together, that's what the little dot means, all you do is take the same base, so if it's like 2, if it's x, if it's 4, whatever it is, you keep that base and you add the exponents together. So here, when I look at it, I have 4 squared times 4 to the 6th. All we're going to do is rewrite it. We don't want to solve it right now or put it as a number. So I do have the same base, which is 4, and my exponents are 2 and 6, so I add them together and I get 8. You're not going to multiply them together because there's a multiplication symbol. That's what your laws of exponents say. This next one, if you have the same base and you are dividing with exponents, you are going to subtract them. It doesn't matter if they're in a fraction or if they have a division symbol, it means the same thing. So I first want to divide my numbers. I have 12 divided by -4, which gives me -3. So that's going to go up in the top because remember this is like over 1. So I have -3 a to the 7th over, you can put a 1 if you need to, a to the 3rd. But now if I look and see the bases are the same, they're both a, they each have an exponent, so I'm going to subtract those. I'm actually going to do 7 minus 3 to get me 4. So my final answer is going to be -3a to the 4th, because all that would be left in the bottom is just a 1, and you don't need to have that there. Law number 3 says if there's something in parentheses and there's an exponent on the outside, you have to give that exponent to everything in parentheses. Numbers, variables, everything. So here I have 3x squared y in parentheses and I have a squared on the outside. So I'm going to go ahead and rewrite it, and you have to give this squared to everything in parentheses. So I'm going to rewrite it as 3 squared times x squared squared times y squared. Now in order to finish this, you're actually going to need another law. So we're going to go through the laws and then we'll come back to this example to finish it. Law 4 is just like Law 3, but it has to do with fractions. If you have a fraction a over b and it's raised to a power, that power goes to the top of the fraction and the bottom of the fraction. Here it says if b does not equal 0, that just means you can't have 0 as the denominator of your fraction. So here you have a to the 4th, and remember, you now have a squared with it, over, I have b, and squared is now with it too. Again, there is another law you need before you can solve this, so we're going to come back to these examples in just a second. Law 5, this is the one that I'm talking about. This says that if you have something in parentheses with an exponent already, and then on the outside of parentheses there's another exponent, so the first one is m, the second is n, you multiply these now. You're not adding the numbers together, you multiply the exponents together. So here, in this case, I have 2 squared and then cubed on the outside. This is a power to a power, so we are going to multiply those numbers together, and I now will have 2 to the 6th. Now you can plug this in or you can multiply it out to get just one number, but this is just to show you the actual rules. So now because we have Law 5, we can actually go back to the other ones and finish solving. So I now know that my top part, you have a to the 4th squared. So this is a power to a power, so we are going to multiply. You have a, and then 4 times 2 gives us 8. And then on the bottom, you can just rewrite it as b squared. Remember, with the b, there's a 1, so technically we are still multiplying. 1 times 2 gives us 2. Because these bottoms or these bases are not the same, we can't do anything else with it, so you're going to leave it as it is. So now on this example, 3 squared actually gives us a number. We're going to go ahead and write that number out. 3 times 3 gives us 9. Now you have x squared squared. Remember, this is a power to a power, so again, we're going to multiply. 2 times 2 gives us 4. And then we can just rewrite y squared. So this final answer would be 9x to the 4th y squared. Now your last law, law 6, this is the one that everyone struggles with. If you have something raised to the 0 power, it equals 1. It is not 0, but this is only when a is anything but 0. So it can't be 0 to the 0 power. So if it's 4 to the 0 power, it's 1. If it's x squared in parentheses to the 0 power, it's 1. Do not say it is 0. So now when I'm looking here, I can go ahead and start distributing that 0 in, right? But if you notice, everything is in parentheses. So this is just like saying 1 to the 0 power. And I just told you that anything to the 0 power is 1. So you can automatically say this is equal to 1. It's going to include it in like multi-step, so like you'll have something else with it in the problem on the TSI, and it is like that on your worksheet, but you need to automatically know that this is equal to 1. Alright, so if you stuck around for this whole video, shout out to you because I'm sure it was annoying listening to me. If you need help on this section, the algebra and radicals, I do have 2 live sessions during the week. Wednesday, it's at 3 p.m. and I'll just be going over radical and algebra stuff. So if you have any questions, if you need help on the worksheet, if you just want to work through the worksheet, that's totally fine too. I'll be on Zoom Wednesday at 3. And then Friday, I'll be on at 11 a.m. So you have 2 opportunities to get your help. If you need it. If you don't need it, or if you just have a quick question, just leave a comment on Google Classroom. We can get it solved. But other than that, make sure you watch all the other videos so we can help you with what you need help on for the TSI.